The purpose of this video is to show you how to find horizontal intercepts when we're starting with a function that's given in what's called standard form or vertex form of a quadratic. The summary that's here is talking about all the different features that we've talked about so far, and it's really only that last one that we have not talked thoroughly about. But just in case you want to check your answers, I'll write down the answers to the other problems that you might do. So you might try those and check against this. So the vertex, for example, of this parabola has coordinates -2, 24. The coefficient in front of the quadratic term, so that's the a in our formula, is -1/6. So since that number is negative, we know that our parabola is concave down, so it has this shape, meaning our vertex is sitting right there, which means that that 24 that we're getting as the output for the vertex is actually the maximum output of the function, or the maximum y-coordinate on the graph. The vertical intercept we know that that's a point that sits on the vertical axis, which means the first coordinate is 0. And in general, if you tell me the first coordinate, I can use the algebraic formula for the function to find the output that goes with that input. So that'll be -1/6, 0 plus 2 squared plus 24. And that's a little fractiony because we'll have -1/6 times 4 in there as a fraction. But if you work out the fractions, that ends up being 70/3, which is 23 1/3. So it's almost up to 24. So we have this picture that this vertex is way up with an output of 24, and as it goes over towards the vertical axis, it falls down just a little bit to 70/3, a little bit less than 24, when it cuts through the vertical axis. All right, so the main point of the video, of course, is that we want to answer that fourth question, which is to find the horizontal intercepts. And this does feel different for quadratics that are written in this form than it does for quadratics that are in the general form. So following along the way we did the one before, the horizontal intercept has this form, meaning the second coordinate is 0, which is what makes the point fall on the horizontal axis. And so the question is, the first coordinate is the one that we need to know, and the first coordinate would be our input. So I'm trying to find an input, and in the language of this particular function, the inputs are called t. So let me get rid of this and highlight here. So my inputs are t's. So I'm trying to find an input t such that so that the output is equal to 0. Now remember, the formula, when we have this algebraic expression of a function, the formula is a formula for the outputs. The result of applying that formula to an input is going to be an output. So what I need to do is figure out what t makes that formula equal to 0. And so now I'm off in algebra land for sure. So this is going to look a little different than the equations we saw before, because we're in this sort of special circumstance where the only variable in this problem, the t, is sort of bound inside of this block. And I'm going to just highlight this block to emphasize that this little chunk, this little blue box, is the only place that the letter t occurs. Trying to make my t's not look like plus signs. So my strategy here is going to be a little different than it was for the quadratics in general form. I'm going to follow the strategy of first isolating this block on one side of the equation. And I know the legitimate things I can do to the equation still hold. So for example, subtracting 24 from both sides is going to clear out that plus 24 on the left. And I'll have minus 1/6 times my box. And am I really going to draw this box every time? Yes, I am. Equals negative 24. So what we're saying here is this stuff goes away, and I have just negative 24 on that side. And then the other step, the second step that I would do would be to multiply both sides by negative 6, because I know that, again, as long as I do the same thing to both sides, I'm not affecting the solution set to the equation. And I know that multiplying negative 6 times negative 1/6 is going to be 1. So those are essentially canceling each other out. So they, by multiplying together to be 1, they essentially go away. And then on the right-hand side, I have negative 24 times negative 6, which is positive 144. So now I know that the box is equal to 144. So the stuff inside the box is equal to 144. Okay, so that's my process to kind of rewrite the equation so that I have just that vertex thing squared part by itself on one side. So let me explain why that's a good strategy for solving this problem. But to do that, I'm going to have to give myself some more space. So I'm going to erase what I have here. If you are taking notes, just pause the video and make your notes, and then catch up. Okay, so we said we had the blue box equal 144 was where we left it off, and now I want to go back and admit that I know what the box is. The box is 2 plus a half squared. So so this means I know that something squared is 144. Well, to find out what you square to get 144 is exactly the definition of the square root. If you ask yourself, I'm going to put it over here, what squared equals 144, your calculator will do that for you with your square root button. Now 144 is not that big of a number, so you may remember your multiplication tables up to 12s to know what your calculator is going to say to that. It's going to tell you the square root of 144 is 12. And so if I know that something squared is 144, my calculator is telling me that that something has to be 12. Now, your calculator is pretty smart, but it's not that smart. Your calculator, all of those buttons on your calculator are functions, and so they are, by their nature, only going to give you one answer to any question. But in fact, there are two numbers that we could have squared to get 144. Our calculator just gives us one of them. But that's okay, because as human beings, we can think about it and we know what the other one has to be. We know that 12 squared is 144. That's what the calculator says. But as humans, we also know that negative 12 squared is 144. In other words, the calculator is going to tell me the positive number that works, but I know, because I understand the way numbers work, that therefore the negative of that same number also would have worked. So I have to use that knowledge here, let my calculator tell me one value, and I'm going to write the word or, and then I'm going to consider the other value. So one value comes from asking my calculator what the square root is, and if it's one that you know, that's fine, but if it's not, we can always ask the calculator what the square root is of the number that's on the right, and it'll tell us, and then we have to know also the negative of that would also have worked. So we're adding our own human intelligence to the problem by adding that possibility. Once we get to this point, now I can just do my normal algebra of subtracting 2 from both sides. So I'll have t equals 10 would be a possibility here. Down here, again, I'm subtracting 2 from both sides, and it'll tell me t is negative 14. So these are my two answers for t. These are the two solutions that I have to this equation. Remember, the original problem was to find the t so that this happened. Since these are nice whole numbers that I got for t, it's very easy to check those back into that original statement. And so therefore, my horizontal intercepts, I'll put them up here at the top. Remember, they have the form something comma 0. So 10 comma 0 would be 1. and negative 14, comma 0 would be the other one for this equation.